I welcome you on today's lesson. My name is Teacher Musana Yusuf, a teacher of mathematics. Today we are going to be continuing with our topic, that is, we are finalizing it, that is coordinate geometry 2 and 1. So we made a review in coordinate geometry 1 where I looked at the gradient, intercept, equation of a line. We discussed how to come up with the equation of a line, how to get the gradient, and all other aspects that we have discussed. So I always inform you that in case you have not watched the first 3 lessons that we did, please don't, unless otherwise you are sure with those. That's when you can watch this lesson. But since learning is continuous, I always expect you to watch the other first lesson. You are on Seremba Online School, and then we are going to be discussing perpendicular and parallel lines and getting the equation of parallel and perpendicular lines. So let us try to mean what are parallel lines. So parallel lines. So two lines are said to be parallel. So two lines are said to be parallel. Two lines are said if they have the same gradient. So if the gradient is the same, if they have the same gradient. So the gradient must be the same. So then that's when they must be parallel. So the concept is, if I have these are two lines, then I've plotted my lines. This is x, this is yx, this is the line, this is another line. This is L1, this is L2. These lines are parallel. They will never meet. So if they don't meet, then they have the same what? The same gradient. So the concept of parallel line is that to find the equation of the parallel line, then what do? You must know that if they give you maybe the equation of the first line, and then they ask you to find the equation of the second line, given a point where the line passes. For example, if this is where the line passes, and I want to get the equation of this line, and I know the equation of this line as mx plus c, then what can I do? I know that since these two lines are parallel, then they have the same gradient. So the gradient is the same. So in that context, you must know the gradient of this line. Sometimes they don't give you the equation when it is directly written like that as y is equal to mx plus c. So sometimes they give you the equation when it is in this form. We looked at this form, so that you have to transform that equation into y is equal to mx plus c by making the y the subject, so that you can be able to come up with the what? The gradient. So what do we do now? What do? What we first do is to know the gradient of the first line. So when we get the gradient of the first line, we shall be able to find the gradient of, that's the gradient of the second line. So the second line, so in other words, if I know the gradient of line 1, so grad of 1 is equal to the grad of 2, of line L2. The reason is they are parallel. So parallel lines, the concept is parallel lines have the same what? Gradient. So in case you want to find the equation of the parallel line like what we shall see, then we should be able to find the gradient of the first one, then the gradient of the second one is the gradient of the first one. So you just find the equation, rearrange it. In case not to arrange, then you are able to tell the gradient of the first line is the gradient of the second line. Well, so what about perpendicular lines? Perpendicular lines. So two lines are said to be perpendicular if the products of their gradient is equal to -1. So if I have two lines like this, so this, and maybe, so if I draw this line and I'm saying it is perpendicular to this, my meaning they make an angle of 90 between them when they meet. So these lines have to meet. So if they are to meet, then they are perpendicular. Then what do we know? If this line L1 and this line L2, what could we tell? What could tell about this line is that each line has got its own gradient. So if the grade of this line is M1 and the grade of this line is M2, then these lines are perpendicular if and only if, should you get the gradient of the first line, the product of their gradient is equal to -1. So the product of their gradient is equal to -1. So in that context, we shall have M1 times M2 is equal to -1. This condition has to be fulfilled in that if these lines are perpendicular. So therefore, two lines are said to be perpendicular if the product of their gradient is equal to -1. So in this case, so if I want the gradient of the first line and the second, I know the gradient of the first line and I want to get the gradient of the second line, I have to divide. So I have -1 over M1. So -1 over M1. It gives you the gradient of the second line. So two lines are said to be perpendicular if the product of their gradient is equal to -1. Now they can ask you a question. They give you two lines and then they ask you which line are they perpendicular or not. So in that case, you should be able to get the condition and multiply the gradient. So I can take an example with you and then you see. Then I ask you this question. Very good. So we can take the example and then we see. So the question says, given, I'll just write it for those that, but we can share this work on the WhatsApp groups and also in our notes that we provide. So we give you some notes, the materials, so you can just find some of these questions there. So in case, but let me write it. Example. Given that, example says, given that the line L, given that the line L with equation y is equal to 2x plus 1, find the gradient of any of the line. Find the gradient of any of the line that is Roman 1 parallel to L. Roman 2 perpendicular to L. So what do we do? Solution? Good. We first ask ourselves, what's the equation of this line? So we want to find the gradient. So y is equal to 2x plus 1. So it implies that the gradient of the line, which is m, is equal to 2. Why? We compare with mx plus c. So in this case, this coefficient of x is always the gradient, if you recall from our lesson. That's why I said you should have watched the lessons that we have discussed under this. So in this case, the gradient is 2. So since we have the gradient is 2, then the gradient of the line that must be parallel to L1 must have the same gradient. The gradient should be the same. That's a concept. So in this case, the gradient of the line, so we say Roman 1 that the grade of the line that is parallel to L is equal to 2. Why? Parallel have the same gradient. That's good. So L Roman 2, the grade of the line, so we say the grade of the line which is perpendicular to L is equal to, we say that it's going to be given by -1 out of m. Now this m is the gradient of the line. Where does it come from? We said if I have m1 times m2, it should give me -1. So in this case, this implies that I know m1, I want to find m2. So m2 will be -1 out of m1. So when you put here m1 or m, we shall get -1 out of 2. So that's the gradient of the line that will be perpendicular to this. So in that case, you have answered the question. So in that case, the question has been answered properly. So we can maybe look at another question. Now, Sean, good. So we can have another question says that you determine whether the lines are perpendicular. The question says, example 2 is determine whether the lines with the equation 2y equals to -6 plus 8 and 3y equals to x plus 12 are parallel, perpendicular, or neither of that. So what do we do? That's just as simple. We can just take still the concept. Solution shall say these are the lines. So 2y, we can call this line 1, which has equation 2y, arrow 1, mean line 1, which is 2y equals -6x plus 8, and L2, which has the equation 3y equals to x plus 12. But these two lines, they are not directly written in the form, they are all not written directly in the form y is equal to mx plus c. They are not. So let us transform them. When we try to transform the first line, we shall have y equals, we divide through by 2. So we shall get 2 divided by 2, it is 1. And then -6 divided by 2, it is -3x plus 4. If you divide this by 2. So when you divide this also through by 3, you'll get y equals a third x, then plus 4. These two lines, this when you divide this, you'll get what? You'll get 4. Now, having got that, we have to compare. So this implies that when you compare with ymx plus c, then this is the gradient of the first line. So m1 is -3, m2 is a third. Now let us see, are the lines parallel? Class, are the lines parallel? No, they are not parallel, because when two lines are said to be parallel, then their gradient must be the same. They must have the same gradient. That's what you should know. So if they are parallel, then m1 and m2 must have the same value. But since they are not having the same value, then they are not parallel. So we are saying that lines L1 and L2 are not parallel. Reason, don't write this in exam because it's me just giving you the reason. Reason is that M1 is not equal to M2. They are not equal. Then Roman 2, we test whether they are perpendicular. If the lines are perpendicular, are they perpendicular? Let us see. We are testing if they are perpendicular. We say if arrow 1 and arrow 2 are perpendicular, then we should multiply m1 times m2 should give us -1. So let us try and see. We multiply. So m1 is times m2. m1 is which? It is -3. m2, it is a third. So this gives you a -1. So that shows these two lines are perpendicular, since they have the product of their gradient gives you a -1. So we say, therefore, the lines L1 and L2 are perpendicular. Therefore, they are perpendicular. Now, what if this also had failed? What if this condition also had failed, whereby we could not get -1? Then the lines would have been neither perpendicular nor parallel. That's good. So that's the concept. And it's all about, in this lesson, we made a very nice introduction about parallel lines and perpendicular lines. So we are going to stop here in this lesson. The next lesson, we are going to be looking at the equation, how to find the equation of the line, or whether the line, after getting the gradient, you have known the gradient, then we can use the concept to find the equation of either a perpendicular line or a parallel line. I wish we meet in the next lesson. Thank you very much.